All right, let's look at this next problem. A spherical balloon is being inflated at a constant rate of 1 cubic inch per second. How fast is the radius of the balloon increasing when the balloon's volume is 90 cubic inches? Give a decimal answer. All right, so first thing we need to do here is come up with the formula for the volume of a sphere. If you don't know that, you can look it up. It's V equals 4/3 pi r cubed. All right. So let's look at what they're giving us. They say that it's being inflated at a constant rate of 1 cubic inch per second. So that tells us dV dt, because that's telling us how fast the volume is changing, is 1 cubic inch per second. And they're asking us how fast is the radius increasing. So they're asking us to find dr dt when the volume is 90. And give a decimal answer. So let's take the derivative of that formula up there, and that'll give us the rate equation we need. The derivative of v with respect to time is just dv dt. And over here, if you take the derivative of this, you get 3 times 4/3, gives you 4 pi r squared times the derivative with respect to time. So now we can plug in, we've got almost all that we need. It says find dr dt when v is 90. So we're solving for this, or no, we're solving for this over here. We know that this value here is 1. We've got to figure out what r is at this instant in time. Now they gave us the volume instead of the radius, so we need to come down here and we need to first find r when v is 90. So to do that, we'll plug back into this equation up here. When v is 90, we got 4/3 pi r cubed. We got to solve that for r. So let's see, I'm going to multiply 90 by 3/4. What's a fourth of 90? 22.5. Anyway, I'm going to multiply both sides of this equation by 3/4. Get 67.5 equals pi r cubed. Slide this over. So from there, 67.5 over pi equals r cubed. So let's see, I'm just going to take my calculator, do 67.5 divided by pi equals 21.48. Got to take the cube root of that, so I'm going to raise it to the 1/3 power. I get 2.7800. Yada, yada, yada. All right, so I get that amount. So I'm going to plug that into this equation over here. So dV dt at the instant we care about is 4 times pi, that was 2.78, blah, 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 squared, times dr dt, which is 1. So let's look at this again right quick. We got 4 pi r, the r that gets squared is this, and dr dt is 1 from, oh, I'm making a mistake. dr dt is what we're solving for. dV dt is 1. So I've got to, I'll get dr dt is 1 divided by 4 times pi times 2.78 squared. All right, now I've still got that 2.78 number in my calculator with all the decimal places there, the full, what's the word I'm looking for? The full precision of the calculator. So I'm going to work this out by doing that. I'm going to do 2.78 squared times pi times 4. Now I've got the denominator of my answer here. To get the answer itself, I'm going to do 1 over that, and I get an answer of 0.010296. I should probably worry about significant figures, but it's math class. We're not going to worry about that. That's our answer, and that is in inches per second.